Thank you for taking my call at such short notice.
Thank you. Thank you for your interest.
Are you okay where you are? It sounds like you're quite close to some dangerous places.
Well, yeah, it's a signal of possible bombing right now, but yeah, but it's okay. It's
Okay. Yeah. Okay. Well, thank you. Are you still able to work at the moment with what's happening in Ukraine?
uh, it's madness. You're in Britain now, yeah?
Yes, I'm in Britain.
Yeah. Okay. Thank you so much for your help. It's real. Yes.
Can I ask you a little bit about eggs?
Yes, sure. Yeah. But I'm sorry, you see, I'm Ukrainian, so maybe my English isn't so perfect to locate it in your video.
It sounds very good to me. Why did you and your colleagues decide to do this research into eggs? What was the interest? Was it sparked by anything?
You see, that was really applied nature at the very beginning, because our basic desire was to evaluate some calculated formulae for calculating egg volume and egg surface area. That was very, very, you see, applied idea, applied desire to do this in such a way. And for that, we were needed to evaluate some equation, and then using the formula of integrating geometry to recalculate them and to deduce some theoretical formula for volumes, for surface area, maybe for curvature, for anything else. Yeah, and we started to evaluate which formula is the best one. So we found the Google-Shaffer's formula, which was deduced by Google-Shaffer in, seems to me, 1944. Well, it was very old, but so we brought it another modern life. But when we started to evaluate it, it was very good for hens eggs or for the eggs of domestic poultry. But then we started to evaluate more shapes, more the shapes of wild eggs of wild species. And we found that there are also very nice, very beautiful pyriform shaped eggs. And we tried to use the same formula, the same equation, the Google-Shaffer's model, as we called it, to such type of eggs, and we failed with it. So it was not so good, so nice, so comfortable for them to describe them with that. So we started to evaluate what is the reason for that, and we proposed such a term as mathematical evolution. So which is could be very similar as we decided, yeah, to biological evolution. So if we consider a sphere, yeah, with only one parameter, which is the radius, and then if we use two parameters, then it will be ellipsoid. If we use three parameters, the third one, so it will be an ovoid, or Google-Shaffer's model. So we decided that we need another one, the fourth parameter, by means of which it will be possible to, using the principles of evolution, yeah, to deduce another more complicated formula. So it appeared to be very complicated. It appeared to be awful from my point. Nevertheless, it works. So maybe tomorrow we will evaluate another very very elegant form equation. But at the moment, it's as it is. yeah. After that, we started to think that maybe this is the such a universal formula which can throw some light to the formation of the universe or something else. So you know, each scientist would need to create something magnificent.
Would you have preferred a more beautiful and elegant formula then? Because the final formula is large, has many
Yeah,
inputs.
yeah. We'd like to have another one. We have at the moment we have another study by means of which it is possible um, to to mathematically describe even a piriform egg by means of only two parameters: egg length and maximum breadth, L and B, as it is shown in the education of our paper. But it's, you see, it's just for applied matter. Not it has no such a theoretical meaning, you know, just to design, to create such type of egg. Yeah, it's okay, it's okay.
So as I understand it, there are 4 parameters.
Yeah,
I understand length and I
yeah,
understand maximum breadth.
yeah.
And then you also have this one that's to do with
The
axis.
shift, we call it, yeah, the you see, um, so it is the x axis, yeah, the horizontal and the vertical one. The vertical one is located at the half of the length, but the axis of maximum breadth, it's a little bit shifted. So this is the parameter W, which we called it. Yeah, this is the shift, exactly the distance between the location of maximum breadth and the half of the length.
Okay, half of the length. And the 4th parameter you use is the diameter at
Yeah,
1/4 along the
yeah.
length. Is that 1/4 from the pointy end or from the blunt end?
From the pointy one.
Okay. And these are the 4 parameters. And then using your equation, I can then plot the X and Y coordinates to draw the shape of the egg perfectly. That's what the
Yeah,
X and the Y are.
yeah.
Okay. How much study did you and your partners have to do into eggs, into real eggs and biology? Or was this all pure mathematics and in your brains? Or did you have to go and learn about eggs in nature?
You see, uh, I'm my major is an engineer, and I was involved in different engineer in poultry engineering. But I I like eggs, egg shaped. They're something very beautiful for me. Yeah, it's I don't know. There are a lot of people who likes eggs.
Yeah.
Yeah.
I-
And
It's called, I hear eggs called the perfect shape in a press release from your team. You called the eggs the perfect shape. Why are eggs the perfect shape?
that is, you see, that is not really my term. That is the term of Professor Birkhead. So he said that the most perfect thing in the world is an avian egg. So I fully agree with him.
You just did you say you are a poultry engineer?
Yes, I'm a poultry engineer. Yeah,
What does a
I,
poultry engineer do?
you see, this is the mostly automated and mechanized field of agriculture, of animal husbandry, let's say.
Okay.
So yeah, 99% of all operations at poultry farm, they are done by vehicles, different devices,
Hmm.
apparatuses. So the feeders, the drinking, even catching birds is also done by means of different mechanisms. So, and the same situation with eggs. So the sorting eggs, collecting eggs, let's say incubating eggs, yeah, and so on. And I'm involved mostly in possible pre-incubational sorting of eggs.
Okay.
So the one of the major problems of poultry science is how to detect whether, according to the gender of the embryo, the sex of the embryo, whether it's male egg or female egg.
You and your team, when you publish this paper, how are you hoping this information, this new equation, this new formula might be used by various fields? What are some of your hopes? How would you like to see this put to use?
You see, we again, not only our term, not only devoted to mathematical evolution, but we also have another term. I suppose our team, me, Michael Romanov, and Professor Darren Griffin. We proposed such a term as egg-inspired engineering. So because there are a lot of different applications. This is the thin-walled vessels, which are very, very useful in engineering.
Mm-hmm.
Then it is egg-shaped antennas. Then, of course, there is also a lot of different art applications, yeah, which used eggs in different you know Fabergé eggs probably, yeah.
Yes.
Very, very famous, the Easter eggs, yeah. Which is, yeah, very close.
Yes.
uh,
Architecture.
Architecture, yeah, sure. Bridges and Gercon, a lot of engineering and architectural construction applications.
I've read now that there are these 4 types of eggs, and you need the extra parameter each time to be able to model it. Is there
Yeah.
a 5th type of egg, or is that it? There are no more types of eggs? There's not enough, you can't have an extra parameter to create a new kind of egg?
At the moment, it seems to me this is the the last war form.
Okay.
This is the pirate form, yeah. At least we don't know, yeah.
Okay.
Maybe paleontology, yeah, is working more and more hardly, yeah. And this maybe we will find something in the former times which was I don't know, concave.
Thank you for your time today.
Thank you. Thanks,
Best
Brady.
wishes to you guys over there, and I hope next time
Yeah,
we talk it's very different.
yeah, okay. Thank you.
Okay.
I do hope to. Yeah.
Okay.
Thanks a lot.
Stay safe, yes? Okay.
Yeah, thank you. Thanks,
Okay.
and thanks again. Thanks again to Britons and to United Kingdom for everything you are doing for us.
You know, it's very, very Game of Thrones. And out it pops. Even though it's an egg that stays up. Absolutely beautiful. Yeah, and it's a mathematical object, and the history of this object is fascinating. It's a great story, and it's also leads to some really quite good fun maths.